I want to show you a couple of initial derivative rules, which are going to help us calculate lots of derivatives as we continue on. And first of all, we can ask ourselves, what's the derivative of a line? So if I have y equals f of x equals mx plus b, you guys remember y equals mx plus b, the equation for a line. What's the derivative of that? So I take any point A, and what's the derivative? There's two ways you can think about this. And the first way is if you draw a graph. I'll draw it over here. So if you look at a graph of that line, and I'll just draw it schematically. If you go back to the geometrically, what's the definition of the derivative? You pick your point x equals a. Maybe it's right here. And then you pick another point, and you look at the secant line. But if your function is a line anyway, then the secant line is already equal to the line. And the slope of that secant line is going to be the same as the slope as your function. So then as you take the limit of secant lines, they're all going to stay the same, and that limit will be m. So whenever you have a line, the derivative is just going to be the slope of that line. So in particular, like what if you had just a constant, like a horizontal line? Then immediately you know that the derivative, another way we might write this is, y prime, and say that's equal to 0. Since y is equal to f of x anyway, it doesn't really hurt you to write y prime instead of f prime of a. The next thing I want to show you is how do you take the derivative of a sum of two functions. So say that you had two functions, f and g, and you add them together, and you want to take the derivative. So this we can solve with the limit laws, because if you remember what's the definition of the derivative, if we take the derivative of this at a point, let's say x equals a, then we write down limit as x goes to a, and we have to plug in x into this function, so it's going to be f of x plus g of x minus plugging in x equals a, so that'd be f of a plus g of a, because remember the function is actually the sum of f and g, and then you divide by x minus a. And what you do is you can just rewrite this as f of x minus f of a plus g of x minus g of a, and then use the sum limit law. So you'll get f of x minus f of a all over x minus a, and then you're going to be adding to that the limit. So x goes to a of g of x minus g of a. And that's nothing but the sum of the two derivatives. So whenever you have two functions and you know how to differentiate them individually, then their sum, you take the derivative of that, and it's just going to be the sum of the derivatives. And that's the same thing as the limit law for sums. And so for a quick example of seeing that in practice, what if I gave you something like f of x equals x squared, and then I added to it 3x plus 4. So now we can take the derivative of this polynomial. And the way I can do it, I can think of x squared as my f of x and 3x plus 4 as my g of x. And so that's going to be the derivative of x squared, which we figured out earlier was 2x. And just over there on the other display, we saw that the derivative of mx plus b is nothing but the slope. So that let me quickly calculate this derivative without doing any extra work.